Alright, let's go to what we call monomials, okay? So monomial is when you have expression with one term. For example, right here we have 4a, okay? You can have a variable and what we call coefficient, or we just call that a number, right? But musically, mathematically, that's what we call coefficient. Alright, what we can do is we can multiply monomials, okay? Or, sometimes we can have more than one variable like this, m and n, alright? Or we can divide monomials like this. Okay, let's start with multiplication. So the way you work this problem out, well, actually, let's start with the bottom one, right? The middle one right here. This is much more easier, okay? So again, the way we work this out is, alright, we're going to multiply the numbers, the coefficients together, and then here, multiply the variables together, okay? So, what's 4 times 2? That's 8, alright? Okay, then we have a times a cubed. I would actually first write it this way, a, okay, times a cubed. Well, this looks familiar, right? This thing right here, this is, right, none other than exponents, right? So we use all the rules of exponents where we multiply two exponents, we add, and write the powers together, right? So remember that if we just have like an a like this a is actually a to the 1 power, okay? Okay, so, alright, let's bring down the a here, 8, sorry, okay? What is this going to be? Okay, we're going to multiply these two, so that means that we have to add the 2 powers, right? Because a to the m times a to the n is m plus n, right? So it's going to be a to the 1, right, plus 3. So that's going to be 8 to the a to the 4th power, like that. Alright, let's actually go to the top one right here. Alright. This one looks kind of tricky, but it's the same rules apply, okay? So we multiply the numbers together, and then we're going to multiply the respective variables together. So we multiply the m's together, and we multiply the n's together. So we multiply the m's together, and then the n's together, okay? So what's 3 times 2? That equals, okay, sorry, that equals 6, okay, and then m times m squared, which is going to be like that, m times m squared, and then we're going to have n squared, so that's going to be n squared, right, times n, okay? So we have 6 m times m squared, and then n, right, n times, n squared times n, right? So let's bring down the 6 here, okay? Let's multiply the m's together, alright? So that's going to be m to the 1st power times n to the 2nd power, so that's going to be 6m to the 1 plus 2 power, right? Add those two together. And then we have n, right? Squared plus n to the 1, right? Because n is n to the 1. So we have 6m to the 1 plus 2 power and n to the 2 plus 1 power. So that's going to be 6 to the m 3rd power and the n to the 3rd power, like so. Okay, what about division? Well, we'll do quotient. Well, it's just like doing fractions, right? It's just that now we've also got variables. Alright, so what we can do, alright, is we can actually subtract, the powers, because these are quotients, right? Or we can just merely start canceling out the factors, okay? So, can we simplify 6 over 36? Yes, we can, right? Because, let's see, 36 goes to 6, right? So the 6 cancels, that becomes a 1. The 36 becomes a 6, right? Alright, what about here? We have x squared and x is 7. We can do some cancellation here too, can't we? Alright, so what we can do is we can you can take the greater power, right, and then subtract that from the lesser power. Okay, so we have x squared, that's less than x to the 7th power, right? So we can subtract 7 from 2. So this x cancels out, and what's 7 minus 2? That's going to be 7 to the 5th power. Okay, then we have y over y cubed. Okay, which one has the lesser power? Y, right? Because that's y to the 1. Alright, so the y1 cancels, and then this y cubed is we're going to take away 1 of it, right? So 3 minus 1 is 2. Alright, so we did some cancellation here. So what's left on the top? We have a 1, and the rest cancel, right? Okay, so the top we just have a 1 over, what about the bottom? We have a 6. What about x? We have an x to the 5th power. And then we have y to the 2nd power. Another way of looking at this is if we actually apply the quotient rules, right? So originally we had x squared over x to the 7th, right? Well, what we can do is we can subtract these two powers, so we get x to the 2 minus 7. That gives us x to the, what's 2 minus 7? That's also 7, negative 7 plus 2. Right, so 7 minus 2 is 5, but since we have a negative in front of the 7, it's going to be negative 5. So we have x to the negative 5. What does that mean, x to the negative 5? Well, remember we said that whenever we have a negative power, that means that it's going to be a fraction. 1 over x to the 5th power, right? Well, let's look here. 1 over x to the 5th power. Do we have that? Well, we do, right? It's 1 over x to the 5th power. Now, if you do the same thing for the y over y cubed, you should get the same idea. It should be y to the negative 2. Alright? So, there's two ways of doing it. You can actually use the power rules that we've been doing, or like the quotient and the exponent rules, or you can do cancellation like so. Okay, now let's go to square roots, okay? So, if we have, say, a monomial that says a squared, right? If we take the square root of it, we're just going to get a, okay? So, a can be a number, or it can be a variable. Let's take, for example, an easy number. How about 4? Okay. Question is, what is the square root of 4? Now, the first thing you gotta do here is you have to factor out 4, alright? And you have to see if you can rewrite this in this kind of form, something squared. Can we reduce 4 into other numbers? Well, 2 times 2 is 4, right? So that works, alright? So that's equal to 2 times 2. However, we can rewrite 2 times 2 as 2 squared, okay? Now, for now, I'm writing like this, but eventually you can, hopefully you can just realize that 4 is 2 squared, okay? Alright, so now we have a similar form here, right? 2 squared, right? That's kind of like a squared, right? So a is 2, so by definition, if a squared of a squared is a, the square root of 2 squared is 2, right? Because 2 is a, so we get 2, right? These have very similar forms, don't they? Alright? Let's try another number. Alright, and I'm going to do numbers that have perfect squares, and it's good to memorize the perfect squares. Alright? So, square root of 4. Let's see. How about square root of 9? Well, what times what equals 9? 3 times 3, right? Notice we're just going in order, right? So it's going to be 3 times 3, which is square root of 3 squared. So square root of 3 squared is just going to be 3, right? Because 3 is a, right? So a squared, square root of a squared is a. See how that 3 came out? Okay, well, what if you have a number that's not, a perfect square? Can we still do square root? Sure we can. What if we had the square root of 8? Okay, so you have to ask yourself, what times what equals 8? Alright, we have several choices. We have 8 times 1. Well, that doesn't really help us, right, to simplify it. Alright, so usually the obvious answer that doesn't work is 1 times that number, okay? Doesn't work. Right, what other numbers work? 2 and 4, alright, 4 times 2 is 8. Alright, so we have 4 and 2 like that, right? 4 and 2, so you can see that. Well, from this point, you have to ask yourself, can you write any of these numbers into, alright, this square root form? Can you write this 2 into square root form? No, you can't. How about 4? Well, we know we can't, right? Because 4 is square root, or is 2 squared, right? 2 squared times 2. Okay? So, when we have problems like this, where we don't have exactly a perfect square, you're going to have some stuff left over, okay? So this 2 squared we can take out, right, because of this rule. We can take it out. So that's going to be 2 squared, square root of 2 squared is 2, right? But we still have that 2 left over in there. So it's going to be 2 square root of 2, okay? So whenever you don't have like a perfect square number, you're going to have something left over. And we have a square root of 2 left over in there. Okay, let's try one where we have a monomial. So we have a number and a letter or a variable. Okay, so let's say we had 16, okay, x to the 4th power, okay, and we're going to square root that. Well, what are the factors of 16? Can we write 16 as a perfect square? Well, what are the factors of 16 that you could use? 2 and 8? Are there any others? How about 4 times 4? Okay, so 6 square root of 16, or 16 is 4 times 4, and then we have x to the 4th, okay? So make sure that you copy the variable term too. Okay, can we rewrite 4 times 4 into this? Yes, we can. Because 4 times 4 is also 4 squared. Right, so that's going to be 4 squared x to the 4th power. Alright? So now, okay, when we have this, what we're going to do is we're going to take the square root of the number first, okay? So what's the square root of 4 squared? Well, using this identity, alright, 4 squared, square root of 4 squared is 4. Okay? Now, there are a couple ways you can tackle these variables. You can rewrite this x to the 4th as x squared squared like that. Or, I like to find, I find this much more easier, is that whatever variable you have, you take the power and you divide it by 2, and it always comes out correct. So, x to the 4th power, what's 4 divided by 2? It's going to be x squared, okay? However, if you have something like this, like x squared squared, alright, you can still use this identity, because x squared is like a squared, so what comes out? Well, x squared, right? So we can use that identity. But what I like to do, alright, because sometimes it's kind of hard to look at this way, is just whatever power you have, especially if it's an even number, you divide that by 2, and then that should give you the right answer. Okay?